We all sit through math class, right? We learn everything from simple addition to, crazy calculus. But have you ever really stopped and asked a more basic question? What is math, anyway? Well, it turns out that one simple question has sparked this huge debate that's been raging for over 2,000 years. So today we're diving into the hidden philosophies behind the numbers. So, on one side of the ring, you've got this really powerful idea that mathematics is something eternal, universal. It's this fundamental property of the universe that exists completely outside of our human minds. In this view, we don't create it, we just uncover its secrets. But then, there's a totally different way to look at it. What if math isn't some cosmic truth at all? What if it's just a tool? A really sophisticated language, maybe even an elaborate game that we humans made up to describe the world around us and, solve problems. All right, so let's really break this down into the two main camps. The discoverers see math as an objective reality. For them, finding a new theorem is like an explorer finding a new continent that was always there, just waiting to be mapped. And then the inventors are like, no way. They see it as a formal system we created. For them, the rules of algebra are no more a part of the universe than the rules of chess are. All right, first up, let's dive into Camp 1, the discoverers. This is the oldest and for a very long time, the most popular view. This is the idea that math is this body of certain, timeless, almost superhuman knowledge. So, the philosophy at the heart of this is called Platonism, named after the ancient Greek philosopher Plato, of course. Platonists argue that things like numbers, sets, and geometric shapes are actually real, genuinely real. They're just not physical things you can touch, and they're not just ideas in your head. They're abstract, existing in their own perfect non-physical reality. So according to Platonists, these objects are real, but they exist, well, outside of space and time. I mean, think about the number 7, right? Where is it? It's not sitting on a shelf somewhere, it just is. These truths are seen as unchanging, eternal. They were true long before we showed up, and they'll be true long after we're gone. Our job then isn't to create math, but simply to discover these deep, pre-existing truths. You can see how this mindset creates this sense of wonder, of exploration. Mathematicians, in this view, are kind of like astronomers, peering through a telescope into this abstract world, just reporting back on the beautiful, unchanging structures they find. Now, this Platonist view leads right into something called absolutism. This belief that because these mathematical truths are perfect and eternal, the knowledge itself must be absolutely certain, totally infallible. And this has huge implications, not just for philosophy, but as we're going to see in a bit, for how we actually teach math in school. Okay, so let's flip the script and check out the other side of the debate. Let's see how they build a completely different picture. This is Camp 2, the inventors. And for them, mathematics is a purely human creation. One of the big ideas in this camp is something called formalism. Formalists believe that math isn't really about anything, not in the real world, not in some abstract world. They basically see it as a game. You start with a few basic symbols and rules, your axioms, and then you just see what other strings of symbols you can logically create. The truths you find aren't about some deep cosmic reality, they're just what happens when you follow the rules we made up. A related idea, maybe a little more human-centric, is constructivism. This philosophy says that math is a product of our own minds, our own intuition. For a constructivist, a math concept only really exists if you can actually build it or prove it in a set number of steps. It's all about the active process of building, not passively seeing something that was already there. So this whole inventor camp, they share a few core beliefs. They see math as a formal system of symbols that we designed. They completely reject the idea that there's some abstract math reality just out there waiting for us. Instead, they believe we actively build new knowledge on top of what we've already learned. And that makes learning a creative, active process, not just sitting there passively absorbing facts. So this whole discover versus invent thing, it actually led to one of the most dramatic showdowns in the entire history of math. See, the inventors, especially the formalists, had this incredibly grand ambition. Okay, so picture this. Early 20th century. A genius mathematician named David Hilbert basically tries to prove the formalist view is the right one. His goal was to create one single, unified system of rules from which every mathematical truth could be proven. And here's the kicker. He wanted to prove this system was perfectly consistent, that it would never, ever lead to a contradiction. I mean, this was the ultimate dream for the inventors.
If they could pull this off, they could put math on a perfectly logical, human-made foundation once and for all. But was it even possible?
And then the whole dream came crashing down. In 1931, this young logician, Kurt Gödel, publishes a paper, and it just sends shockwaves through the entire mathematical world. This is Gödel's famous incompleteness theorem. And what it proved, in simple terms, is that any math system that's powerful enough to do basic arithmetic will always have statements inside it that are true, but that you can never prove are true using the system's own rules. This was just a stunning blow to the formalist project. But even more than that, it showed there's a fundamental limit to what we can know. Even in the pure logic of math, some truths just lie beyond our reach. The search for a single perfect system was officially over.
Okay, so right about now, you might be thinking, this is all really interesting philosophy, but what does any of it have to do with me? Well, it turns out these ideas have a huge, direct impact on a place you know very, very well: the classroom. Just take a look at this comparison here. On one side, you've got the absolutist classroom, the teacher's job to transmit knowledge. Your job, you're basically an empty vessel waiting to be filled. The whole point is just getting the right answer. But then look at the constructivist classroom. The teacher is more of a guide, a facilitator, and you're an active builder of knowledge. Here, it's not just about the right answer, it's about how you get there, the process. So which one of these sounds more like your math class? Be honest.
So, after all that, after exploring both sides, we're back where we started, with that central question. Now that you've seen the arguments, the history, the real-world impact, where do you stand? Are you a discoverer? Do you believe math is this universal, timeless truth that's just woven into the fabric of the cosmos and we're just finding it? Or are you an inventor? Do you believe math is one of humanity's greatest creations, this incredibly powerful tool we designed to make sense of everything?
Look, there might not be a single right answer here, but the next time you're solving a math problem, just pause for a second. Think about this. Are you a discoverer, charting some unknown land that was always there? Or are you an inventor, building something completely new with a brilliant set of tools? The answer, well, it just might change how you see math forever.